how to check monotonic and find the local extreme of the function. What method we can use? Okay, we can use derivative to check the derivative. We can use derivative. When if we need to find local extrema, we draw the table of variation. Table of variation. What need to do next? We find the asymptote. Okay? Asymptote. 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 Find asymptote. The final. We draw. Okay? Sketch. We sketch the graph function. Okay, you want to sketch the function more and more exactly. I think we need to list some special point. For example, we list the intersection between the x-axis, y-axis, and graph function. Okay, and need the local maximum point. Okay, now let me give you an example. We want to draw the graph function. Example. We want to draw the graph function y equal x squared over x squared minus 1. Now, we want to draw the graph function. Now, we follow the six step here to draw the graph function. Now, the first, you want to find the domain of function. What's the domain? What's the domain? Domain of function y is contained the own x is make the function y we find. Okay? The domain of function is contained the x simplified x squared minus 1 not 0. Okay? Not 0. Okay. This is here you can find equal the r minus 1 negative 1. Okay, I think if you need to find the domain of function. To continue, we want to check monotonic property and find the local extrema. Okay, I think we need to use the derivative. To continue, we find the derivative of function and check the sign of derivative. Y prime. What value? Okay, I think we need 3 graphs. We need to rewrite the function here is equal 1 plus 1 over x squared minus 1. Okay, we find y prime is equal minus 2x over x squared minus 1 squared. Minus 1 squared. Okay, this way on the formula of y prime here. We can check the side y prime. Y prime equals 0 if and only if x equals 0. Okay? Y prime positive. What do you think about the value of x satisfies this condition? Negative. Okay? That's answer 0. Y prime negative. Okay. Equivalent to x positive. X positive. Based on the side of y prime, okay, we can accept the table of variation. It's based on the table of variation we can know the function increasing or decreasing sum on interval. To continue, we express the table. The table. X, y prime, y. Okay. Indeed here the x belong to 0%. So we have the x value from the minus, okay, negative infinity to infinity. Okay. To continue, we list some of the space of x. For example, x equal 1, negative 1, and 0. Negative 1, 0, 1. Okay, I think you know the function y not defined at negative 1 and 1. Okay. At 0, we have the y prime equals 0. Now, continue, we add the sign of y prime. Y positive with x less than 0, f less than 0 here. So we have the value here positive. Continue, when f positive, we have the sign here negative. It's based on the sign of y prime. Okay, I think you know the function y increasing or decreasing. For example here, you know the sign between negative infinity to negative 1, we have the sign y prime positive. So in this interval, the function increasing. Okay, we draw the function increasing. To continue, the interval negative 1 to 0. Okay, we have the sign the positive. So the function here increasing. Okay, it's negative decreasing. Okay, so finally we have the function decreasing. Okay, we want to complete the table. We need to take the value. Now, what value? The value here is equal to value of function y when x tends to negative infinity. So we can find the limit y when x tends to negative infinity. What value? Okay, I think the way on the formula. If the x tends to infinity, we have the value y tends to 1. Okay, so tends to 1. So we derive the value here is 1. So similarly, we estimate the limit when x tends to positive infinity y. So we can take here is 1. Okay, now continue. What value? So here, imagine to the limit of function y when x tends to negative 1 from the left-hand side. Okay, does that mean we have the y as the negative 1, negative, what value? Imagine to the left-hand left hand limit of function y at negative 1 is equal to limit y when x tends to negative 1 from the left hand side. What value? X tends to negative 1 from the left hand side. This that mean x tends to negative 1, x less than negative 1. X less than negative 1, we have the x squared minus 1 positive tend to 0. So we have the value here tend to positive inferiority. Positive inferiority. Positive inferiority. Now similarly, what value? Right hand limit of function y at negative 1, what value? What value? X tend to negative 1 from the right hand side. This that means x tend to negative 1. X greater than negative 1. X tend to negative 1. Okay, we have the x squared minus 1 positive, actually negative. So the value here tend to negative inferiority. Okay, negative inferiority. Negative inferiority. Okay. So similarly, you can have the negative inferiority, positive inferiority. What value? X equals 0. X equals 0. 0. Okay, I think we finish the table of fraction. Okay. Based on the table of fraction, of course, we can sketch the ground function. Okay, but I want to draw the ground function more exactly. I think we need to activate asymptote. Okay, we need to activate asymptote. Now, continue. We need to find the asymptote. Asymptote. If you want to find asymptote of function, I think we need to divide the sources into 3 phases. Okay, I think we consider 3 phases. Okay? Now, phase 1. Phase 1. X tend to finite. Y tend to BNT theory. Now, we need to predict what value is. What value is? X tend to A. X tend to A. If the A is not Bn, okay, this side here we call Bn. Bn plus, minus, okay? Oblivion for that we reach Bn. Okay? Bn1, yeah? Bn1. Now, we need to predict A. We need to predict A. If the A is not Bn1, we have the when x tend to A, we have the y tend to A squared over A squared minus 1. Find out. Okay, don't satisfy these conditions. Okay, rotated partial correction. So if you want to make the y tend to PM equally, okay, we need A equal PM. Okay, equal PM. So I tend to find out y tend to equally equivalently to A is equal
BM1.
PM. Okay, PM. It does mean in this case we have two variables. Two variables, that means we have the two
Two vertical
vertical asymptotes. Okay? We have the two vertical asymptotes. Vertical asymptotes.
vertical đúng.
Two vertical asymptotes x equal 1. X equal negative 1. Two vertical asymptotes in this case. Okay, now continue K2. X tend to PM equally. Y tend to B. Now we need to predict B. X tend to equally. Okay, when X tend to PM equally, I think we can activate the limit 1. Okay, we can activate the limit 1. So I think in this case, we can express the limit 1 when X tend to equally. Okay, before you predict B, okay, I think we need to activate the limit 1 when X tend to PM. When X tend to PM equally, based on the formula, when X tend to PM equally, we have the limit here equal what? Equal 1. Equal 1, okay, B equal 1. Okay, this does mean K2 we can obtain, okay, 1 horizontal asymptote, okay, horizontal asymptote. Horizontal asymptote. Y is equal 1. Y is equal 1. Horizontal asymptote. Horizontal asymptote. Okay, now final.
Đấy.
The final.
Y như ta viết đấy.
K3. X tend to PM equally. Y tend to PM equally. If the K here happen or not? No. Okay. You can see when X tend to PM equally, we have the Y tend to finite. So the K here doesn't happen. Okay? Doesn't happen. Okay? No happen.
Không, nó đấy là
From 1. There isn't any slant. Asymptotes. Slant asymptotes. Okay? We need to find all asymptotes of this function. Okay? If we need the step find the own asymptote. Okay? Now continue. We want to draw the graph function. We want to draw. Now, if you want to draw graph function, what you need to do first? I think we need the old special point. Okay, this maybe we need the point intersection of the graph function and x-axis and y-axis. It's maybe. To continue, we can need some local extreme point. It's maybe. Okay, we need some special point. Okay, special point 0. Okay, 0. This point 0. Intersection 0. Okay, so we have only one special point. Okay, when if we need to leave some special point, what we need to do? We need to draw asymptote. Okay, we draw asymptote. Okay, based on the step here, we have how many asymptotes?
3.
3. Okay, 3. 2 vertical and 1 horizontal asymptote. Okay, we draw that. Okay, we draw the horizontal asymptote. And 1. Okay. Now, to continue, based on the table of variation, we draw the graph function. Now let's see. When f varies from the negative infinity to negative 1, we have the value y increasing from the 1 to infinity. From the 1 to infinity. Okay? Sorry, negative 1. Sorry, some text. Okay. Submitted here. F equal 1. F equal negative 1. Okay, submitted. Negative 1 and 1 is not 3. Okay? Okay, negative 1. 1. 1. Okay, from the infinity, the interval from the infinity to negative 1, we have the function increasing from the 1 to infinity, 1 to infinity. So we have okay, 1 to infinity. 1 to infinity. To continue, we consider the behavior of function on interval negative 1 to 0. Negative 1 to 0. Negative 1 to 0. We have the value function increasing from the negative infinity to 0. To 0. Okay. This interval we consider. The interval we consider. Okay, is this 0? To continue, from the interval 0, 1, we have the function decreasing from 0 to negative infinity. Okay, can I draw that? Yeah. Okay. The Okay, now continue. Is it here we draw? We draw the function. If a function has the formula y equal mx, y equal mx, does that mean we know the formula of curve? Sometimes when we know the curve, but we don't know the formula, we don't know the relationship between x and y. We can express the y as a function of x as a function of y. It's not easy. Not easy. The curve. If you don't know exactly y as a function of x, sometimes we can express the x and y by the parameter t. Okay, does that mean we express the x, y by a different variable? Okay, now we consider parametric
trường hợp khi mà viết cái formula ngữ còn
parametric curve.
còn đâu cái đây là thầy đang dặn là không biết formula là gì.
Parametric curve. Parametric curve. We consider the curve to belong to OFY plane. The curve we don't express y as a function of x or x function of y. In such case, we express the curve here by the equation f by the xt, y by the yt. Does that mean we express the x, y by the different variable t? Okay, t. When we express curve by this form, the curve is called parametric curve. Đường cong tham số. Parametric đường cong tham số. Đường cong tham số. Okay. The equation we express parametric curve. The equation here is called parametric equation. Equation here is called parametric equation. Phương trình tham số parametric equation. The variable t is called parameter tham số. Parameter tham số. Okay, let me give you a example. We consider the circle. The circle has the radius 1. The center at top. Radius 1. Now, circle. The circle has a radius 1 and center as origin. The circle here, when we express by the equation x squared plus the y squared is equal 1. Okay? Equal 1. It's very logical question. If you want to express the y as a function of x, we have the two formulas. It's two formulas. Y is equal bn square root 1 minus x squared. Okay? Two formulas. But if you want to express the circle here by primitive equation, we have the only one formula. Now let's see. We take this point M, have the coordinates xy. It belongs to this curve. We can denote the angle here by t. Okay, I think we can estimate the x. We can estimate x. X is equal radius is times the cosine t. Okay, we have radius 1. So we can estimate x is equal cosine t. Y is equal sine t. Okay? Does that mean we can express the circle here by derivative equation? X equal cosine t, y equal sine t. Okay? Is it not a standard equation? It's not standard equation. Ở đây thì những cái phương trình gọi là phương trình y bằng x thì gọi là phương trình tiêu chuẩn hay còn gọi là standard equation. Được chưa nhỉ? Nhé, gọi là standard equation cũng được các bạn. Nhé. Phương trình tiêu chuẩn gọi là phương trình standard equation. Okay, here we can express the circle here by derivative equation. Okay, we have some questions for that. If you know the curve, derivative curve, how to estimate the tangent, how to estimate the normal line of curve, how to estimate that, I think it's not easy. Okay? Now, tangent. The tangent lines. How to tangent lines? Okay. We can denote the curve. The curve here by C. We take this point M0. M0 belongs to C. Has the coordinates x0, y0. Now we want to find the tangent line. That's this point M0. The tangent line at M0. Have the coordinates. How to find that? How to find the tangent line? Now, the formula I think you know. The formula for tangent line. The formula is equal dy over dx at m0. This is times x minus x0 plus y0. Okay? I think you know the formula for tangent line. That's this point m0. That's the formula. x0, y0. I think you know. It's y on m0. Okay? To complete, you need to estimate. Okay, you can see x equal ft, y equal yt. dy over dx, what value? Dy, I think you know dy is equal y prime t dt. Okay, here is based on the formula dx is equal f prime dx f prime dt. I think you know that. So dy over dx, okay. dy y prime t dt dx f prime t dt. Okay, so we can erase dt. We can erase the dt if we belong to numerator and denominator. Okay, when we leave here is equals y prime t over f prime t.
Yes.
Okay, now we return to here. We return to here. We want to estimate the derivative function y. We then make to m at this point m0. M0. What value?
Y phải t trên x phải t.
dy over dx at m0 is equal m0 equivalent to t0. T0 x0 x0 y0.
Là y phải trên
M0
x chứ.
we have the x0 is equal sin t. I'm sorry, cosine t. Y0 is equal sin t. Based on this equation, we can find that t is to make the cosine equal x0. Sin t is equal y0. Okay, from here we can find the t0. We can find t0. So dy over dx at this point m0 is equal y prime t over f prime t. At this point t equals t0. Okay, that means it equal y prime t0 is equal f prime t0. Okay. Based on formula here, we can estimate the equation for standard line. Okay, I can write out here. Okay? You can write down. Now, we return to this example here. We return to this example here. Now we want to find the tangent line of this curve at this point. We take this point m0. M0 is belong to this circle. Have the coordinates the 1 over square root 2. 1 over square root 2. Now we want to find the tangent line. What's the tangent line? Okay, now outline the formula here. Find the tangent line of this circle. At this point m0 have coordinates. Coordinates tọa coordinates. Okay, now based on the formula check the line here.
Một
Okay. Now, how to find the tangent line? Okay. I think you know the parametric equation of this circle equated by this f equals cosine t, y cosine t. Now solution. M0 is hypothetical. This time we may have the M0 is equal 1 over y0 is equal 1 over square root 2. Okay? From this, what T0? Equivalent to T0, what value? Is that mean we solve the equation? Cosine t is equal 5 over 4. Okay? 5 over 4. 5 over 4. To continue, we need to estimate the derivative. Estimate the derivative. dy over dx at m0. What value? Y. It has to do the sine t. X cosine t. Okay, I think you can see. dy over dx is equal to y prime t is over f prime t at t0. Y is equal sine. Okay, is equal y prime is over f prime at t equals t0. Is equal y prime cosine t f prime minus sine t. At t is equal to 0, pi over 4. What value? Negative 1. Okay. Cái từ này các bạn là những số tự nhiên số như thế này, các bạn có thể một hoặc có thể đọc là minus 1 cũng được. Còn thường người ta đọc sẽ đọc là negative 1. Được chưa nhỉ? Còn đây không phải là số, đây không phải là số, là cái gì đó, thì đọc là minus cái gì đó cũng được. Còn bình thường là số thì thường anh người ta hay đọc cái này là negative. Rồi nhỉ? Negative 1. Minus được không sao, đấy là chuyện thoải mái nhé. Nhưng mà cái thông dụng nhất là hay đọc là negative 1. Okay. This is here we estimate the derivative of function y with respect to f as this one m0 is equal negative 1. To continue, based on the formula of tangent line, okay, we can replace the tangent line at m0 is equal. Okay, similarly here, we can estimate the negative 1 as x0 1 over square root plus the y 1 over square root. Okay, I think you can derive. You can derive negative minus x, okay, minus x plus square root 2. Okay, we can find the equation for tangent lines of the parametric curve. Okay, now continue. I want to mention to the how to find the asymptote of parametric curve. How to find asymptote of parametric curve. So similar to the graph function have standard equation. Okay, we consider 3 case to find the asymptote of parametric curve.
Em phải tìm lô một line.
Yeah, I can play that.
Có tiếp tuyến và tìm sát tuyến.
If you need to write out,
quên tiếp tuyến là thanh chỉ là
okay, now you listen to the asymptote. Asymptote of probability curve. A probability curve and a probability equation. Okay, we consider three cases. We consider three cases. X, K1. X tend to A. Y tend to infinity. Pn infinity. Pn. Okay, we read the sign here. Pn. Pn plus minus. Okay. We read the Pn for abbreviation. Pn. Pn infinity. Okay, it's a scale. It's a scale. When y tend to Pn infinity, I think we can activate the T0. Okay? We can activate the T0 corresponding. X tend to A, Y tend to Pn infinity. It's a scale. I think we need to find the T0 corresponding. T0 is that mean when T tend to T0, we have the X tend to finite, Y tend to Pn infinity. T0 corresponding to that. I think we need to find. When we find the T0, the existence of T0, we can talk that the curve have vertical asymptote. Okay? Vertical asymptote. Vertical asymptote. Vertical asymptote x equals. Okay, I think we finish the first case. To continue, case 2. X tend to Pn infinity. Y tend to B. Okay? The similar to K1. I think you need to find the T0. T0. If the T0 is shifted, we talk that the curve have horizontal asymptote. Okay? Horizontal asymptote. Horizontal asymptote. Y is equal B. The final case, case 3. X tend to Pn infinity. Y tend to Pn infinity. Okay, of course, we have the T0 corresponding. This way on T0 here, we find the slant asymptote of this curve. Slant asymptote have the coefficient A and B defined by A is equal the limit y over x when t tend to T0. Y is equal the limit y minus the ax t tend to T0. We have the asymptote, slant asymptote y equal slant asymptote y is equal to ax plus b. Okay? AB defined by this formula. Okay, now let me give you an example. Let me give you an example.
Và các bạn của chị trước nữa. Thì các bạn có biết
Now, we consider current figure have a current equation. X equal t minus exponent t, y equal 2t plus exponent minus t squared. You want to find asymptote of the curve. You find asymptote. X equal t minus exponent t, y is equal 2t plus exponent minus t squared. Okay, now we want to find the own asymptote of this curve. I think we consider the three curve. Okay, and go over the three curve here. K1, K1, S tends to A, finite, Y tend to Bm infinity, Bm infinity. Now, how to find A? How to predict A? How to predict that? Now, T0, what does it mean? T0, what value? Y tend to Bm infinity, equivalent to T0 what? T0 what? T tend to T0. What value T0? What value T0? What value T0? It makes Y infinity. So first, T0 finite? No. Even T0 finite, we have the limit here when T tends to 0 finite. It's not finite. So T0 is maybe Bm infinity. It's maybe. It's maybe. Okay? It's maybe. Now, we need to predict T positive infinity. When T tend to positive infinity, we have a limit here. Tend to infinity, tend to 0. So some here tend to infinity. Good. Okay? So T0 is maybe T0 positive. Infinity. Continue. T0 equal negative infinity. Now we check that. When T tend to negative infinity, what do you think about value here? Tend to T tend to negative infinity. Similarly, tend to negative infinity, tend to 0. So some tend to negative infinity. So we have two values T0 75. T0 75. Okay? To continue, we check if the T0 is equal. Synchronization here 75 or not? I think we need to check. When t0 tends to positive infinity, f tends to 1. What is the two formula? If the t0 equal positive infinity, it doesn't mean t tends to positive infinity. What value? What value? Negative infinity. Okay? Negative infinity. Negative infinity. To continue, if the t tends to negative infinity, what value? What value? Is it here tend to 0? Is it here tend to negative infinity? Okay? So x tend to negative infinity. Now, what conclusion? What conclusion about asymptotes? No. Okay. Because f is not tend to finite. Okay? Not tend to finite. So the function here have no vertical. Okay? No vertical asymptotes. No vertical asymptotes. No vertical asymptotes. Okay, now similarly, K2 and tend to B and infinity. Y tend to B. F tend to B and infinity. F equivalent to T0, T tend to T0. What T0? Yeah, we need to predict T0. We need to predict T0. What T0? T0, upon T0, PM infinity. Okay? F T0 will equal positive infinity. If the t tends to positive infinity, the value here tends to negative infinity. Okay? Negative. So we have the t0 is equal to negative. Positive? Okay. We have the two values, t0. Positive and negative. Now, if the t0 is equal negative, what value y? What value y? If T0, if T tends to negative infinity, what value? Negative. Okay. What value? Y tend to?
Positive.
Positive. Not finite. Not finite. Okay? Not finite. So in this case,
No.
the graph function has no horizontal asymptote. Okay? No horizontal asymptote. No horizontal asymptote. Okay, now final case 3. X tends to PM infinity. Y tends to PM infinity. What is it? Okay, in this case, I think digital is equal. Negative and positive. Two value here 65. Okay? Two value here 65. Okay. Now we want to find the slant asymptote of this equation. Here we have two values t0. So we consider t0. Now the first t0 is equal positive period. Now we want to find the slant asymptote is going on. Now amplify A and B. Okay, here is B. Okay, I think some distance here we have it correct. B is equal. Okay? Okay? Only correct. We say that A B is not Y. Now, amplify the A and B. Amplify the A and B. Okay, now t equal 40 infinity, A, the limit y over x is tend to 40 infinity. Is equal the limit t tend to 40 infinity y, okay, the formula 2t plus exponent minus t squared over t minus exponent t. Now, amplify the limit here. Amplify the limit. Okay, simply you can use the computer rule in such case. The limit we consider here belong to form equally over equally. Okay? So we can use the computer rule in such case. Now, can we activate the limit of the limit? How many? Okay, now, I think the limit here belongs to form equally over equally. So we can use the computer rule just that. Probably the limit t tend to positive equally can be 2 minus 2t exponent minus t squared over 1 minus. Okay.
Em thấy đâu chết ạ? Em thấy không làm được.
Okay. Is it here we can
Lại quy đổi ra rồi sao?
we can divide the both side. No. It's equal. I think we know the exponent function always tend to infinity higher and higher than t. So we have the bracket here tend to 0. Tend to 0 when t tends to infinity. So the limit here is equal to is over. When t tend to positive infinity, we have the value here tend to infinity.
Không
Okay? Equal 0. Now, continue. Find the b. What b? What b? B is equal to limit t tend to infinity y minus ax tend to t0 is equal to limit t tend to positive infinity y okay 2t plus exponent t squared a equal 0. Okay, equal. Is equal. What value? When t tend to positive infinity, we have value here tend to 0. Okay? This here tend to positive infinity. Now, b equal to infinity. What if I talk about the slant asymptote? Okay, no. Okay, no slant asymptote. No slant asymptote. No slant asymptote. Okay, is it here? The first case, it matches to the t equal positive infinity. Now, similarly, can we change the case? t0 is equal negative infinity. What's a? What's a and what b?
chắc là A sẽ A phải sẽ B thì chắc là trừ trừ không
Okay. Now, having find slant asymptote is a t0 and for negative infinity. cos A. 2, okay? Limit t tend to negative infinity, y 2t plus exponent t squared over x t minus 50. Now, how to find the limit here? I think the limit here it belongs to form equally over equally. So we can still apply Hop's rule suspect. The same. Again, for simplicity, can be like here. T0 infinity. Okay, is it here? You can see when t tend to negative infinity, we have the numerator 10 to 2. Denominator, when t tend to infinity, we have the exponent here 10 to 0. Okay, so we have the denominator 10 to 1. Okay, you can estimate. So a equal to Okay, now continue. Let me find the b. Continue. Find the b. Find the b. Why? Okay. This is here we have the a equal 2. Okay, we can figure here t tend to negative infinity. Okay, here the exponent minus t squared plus the 2 exponent t. When t tend to negative infinity, we have the value here tend to negative infinity. So 0. Okay, 0. Okay, we find a equal 2, b equal 0. Okay. And we have slant s plus y equal 2x. Okay, now continue using to the coordinate of 1. It belongs to over y plane and over plane. Okay, now we have the best. We have the best. O at y coordinates. Polar coordinates. Đây là tọa độ ở trong mặt là OXY, còn đây là tọa độ cực tên gọi. Okay, now consider the point M. It belongs to plane. I want to determine the point M. Where the point M lies? I want to know that. You want to determine the where the M lies. It may be in the OFY plane. For example, if the M belongs to OFY plane, we can determine M by the coordinates x and y. Okay? Does that mean we use the coordinates OFY to determine M. M have coordinates at y. Sometimes we can determine the M by the different way. For example, if you denote the angle here by var feet. We denote the distance OM. The distance here by R. The angle, the distance. Okay. Of course, we can determine the M. It's based on the R and bar feet. Okay. This may be from the axis. Okay, we turn the alpha angle. So we can estimate the distance, we can define the M. This means we can determine the M by the square R and bar feet. The square R bar feet here is called polar coordinates. Polar coordinates of M. Polar coordinates. Tọa độ cực của điểm vọng. Còn đây gọi là tọa độ OI của điểm vọng. Tọa độ OI này hay còn gọi là standard coordinate của điểm vọng. Standard coordinate hoặc có thể gọi là Cartesian coordinate. Rất nhiều tên gọi nhưng mà đây là tọa độ tiêu chuẩn, và tiêu chuẩn thì sẽ có tên gọi của nó là standard coordinate. Okay, of course we have the change form between O and Y coordinates and polar coordinates. Now you can see based on the graph here, we can estimate quarterly F equal R cos bar phi. Okay, Y is equal R sin bar phi. Okay. We have the transform between OFY coordinates and polar coordinates. Okay. Okay. Now let me give you an example. We have this point M. Have the OFY coordinates. OFY coordinates 1, 1. Now find polar coordinates of M. polar coordinates. Now, 5 polar coordinates. This means you can find Buffy and R. Okay, I think you can draw X, Y. Okay, this one here. You can see this shape, the square. Okay, so we activate the angle here 5/4. Okay, to continue, it must do listen 1/1. Okay, it's by on the Pythagoras formula. You can activate the listen here is equal to square root 2. Square root 2. So you can find polar coordinates square root 2 5/4. Okay, we have the polar coordinates of this point M. Cái nội dung thi dự kỳ là hết phần đầu nhé, hết phần này nhé. Nội dung thi dự kỳ là hết phần này. Từ đầu đến hết phần này. Okay, now next one we study indefinite integral. Indefinite integral. Integral is phần này. Indefinite là không thể. Tức ở đây là tích phân bất định. Indefinite integral, tích phân bất định. Okay. Before define indefinite integral, we must do the antiderivative. Now, I think we write out definition. Definition of antiderivative. A function f is a co-antiderivative of f on an interval I if capital F prime equal fx for all f belong to interval. In that case, capital F is co-antiderivative when time. Antiderivative when time. Okay. Example. We have two functions, x power 4 plus 2 and 4 f cubed. Very easy to see the derivative of this function is equal. So the function here, empty derivative of 4f cubed. Okay? It's very on the property side. Based on the question here, empty derivative of function is a function, only one function. Satisfies the condition f prime is equal. Only one function. We have a question. How to find all antiderivative of function? How to find? I think it's not easy to find. Okay, not easy to find. If the function f complicated, okay, if you want to find the antiderivative, it's not easy. But we have the relationship between antiderivative of function f. We know that. Before that, I think you know the property. F prime x identical with 0 for all x belong to IB. I think you have property. F prime x identical with 0 for all x belong to IB. If and only if f x constant. I think you know that. Okay, it's based on the Lagrange term. Okay, let's see that. Now we need to find antiderivative of function. Let's see the term. If the antiderivative of function f on I, then the family of all antiderivative of f always has a form. Fx plus c. Now let's see. We consider the two antiderivatives f and z. F plus z prime equal f. The relationship between two antiderivatives here. Now let's see. If the f prime equals z prime equal f, we can imply f minus z prime equals 0. The function f minus z prime equals 0 we return to this property. If the function f satisfies this condition, the function f constant. From here, if and only if f equals z plus constant, z equal f plus constant. Okay? Does that mean if the z antiderivative of function f, z always has this form. Okay? So this from here describe complete form antiderivative of function f. Okay. To continue, we have definition related to indefinite integral. The family of all antiderivative of function f is indefinite integral of f. I think we need to differ antiderivative and indefinite integral. It's not the same. Antiderivative only one function. Indefinite integral, the family, a lot of antiderivative. Okay? It's not the same. Not the same. Let me give an example. We have the function f in f equal to x. This may be we have the antiderivative. Capital Fx is equal to x squared. It means to the indefinite integral. What value? The family, you can decrease as equal x squared plus c. Okay? The c is belong to real number sets. But not the function. Okay? Is no confusion we already denoted by. Denoted by this maybe is misunderstand that one function is not one function, it's here a lot of function. Okay? No confusion, you already denoted by. Ở đây còn là cái chút là nguyên hàm thì nó là một hàm. Còn tích phân bất định, mặc dù công thức cũng giống nguyên hàm nhưng nó sẽ một họ tất cả các nguyên hàm và nó khác ở chỗ là nó số C nhìn thấy chưa nhỉ? Nó khác ở hàm số C và hàm số C là cái thiên. Bình thường viết thế này thì rất dễ hiểu ngầm là tích phân bất định là một hàm, dễ hiểu nhầm, đúng không nhỉ? Thế nhưng mà không có gì nhầm tất cả vì tất cả chúng ta làm thì đều rất thông thường, cho nên người ta chấp nhận là chúng ta viết được cái nguyên hàm kia bằng cái biểu của C. Vì thế này, còn bình thường là chúng ta sẽ biểu diễn nguyên hàm và biểu diễn cái tích phân kia là một họ. Được chưa nhỉ? Khác nhau nhé, khác nhau. Thôi đây không quan trọng lắm, mà để bạn phân biệt thôi. Okay. Now to continue, we have the basic table. Basic table is to do the indefinite integral of some basic function. Okay. Table indefinite integral for some basic function. I think you need to remember, you need to learn by heart this table. Very useful for you to do your exercise.
Let us write down.
You need to learn by heart.
Chụp không chụp ai là bạn hãy ghi ra xuống để write it down.
Basic integral. So if you want to find indefinite integral of some function, okay, I think you need to take some methods to change from the indefinite integral to the table, to the function equivalent table to activate. Some property you can use to change form. The first, imagine to the linearity. the integral sum, therefore the sum of two integral. Okay? To continue, we can check the question after